humans have an irrepressible desire to explore. We are on an unending search for what else is out there. We peer into faraway galaxies. We walk in space. We send rovers to Mars. One element happens to be there every step of the way. This is the story of gold propelling us to the next frontier.
We've all looked up in awe and wonder at the sky, at the vastness of the cosmos. We've all wondered what it must have been like to be one of those astronauts in the early days of spaceflight. But one thing you might notice when you look back at those photographs of the middle of last century, something a bit unexpected perhaps about space, is that there's quite a lot of gold.
In 1965, Colonel Ed White brought gold to space. When he made history with America's first spacewalk, he used a gold-coated visor to protect his eyes from harmful solar radiation. And he was tethered to NASA's Gemini 4 with an umbilical cord wrapped in a protective layer of gold. Since then, hundreds of missions have helped advance our knowledge of the unknown, and a whole lot of them used gold. It was an important element of the Space Shuttle orbiter, the spaceplane frame which has been called the brains and heart of NASA's space transportation system. Gold coated the orbiter's large fuel cells, providing the reliable source of electrical power. Gold was even entrusted with carrying information about life on Earth, should anything out there be curious.
In 1977, aboard the space probe Voyager 1, scientists sent a time capsule out into the galaxy in the form of a 12-inch gold-plated record. The idea being that if the record was ever found by an intelligent extraterrestrial life form, they could use it to get a sense of our planet. On it, they included sounds of life, greetings in 55 different languages, musical compositions, and even images of the human experience encoded into audio waveforms.
Gold was selected for the coating because it protects against radiation and extreme heat. The record and its twin aboard the Voyager 2 are sealed in aluminium cases and now floating out in the inert environment of space, which might just make them the longest surviving human-made objects ever. So when it comes to space, why is gold such an important material?
When you send a spacecraft off to the outer planets, you cannot repair it. You need durable materials, and that's why you use gold. My two main missions are, you can see one on the left side, it's Cassini, which went to Saturn. And on my right side, you can see the JUICE mission. JUICE is an acronym. It stands for Jupiter Icy Moons Explorer. And will launch next year in August 2022. Cassini was actually launched in 1997. It took 7 years to go to Saturn, where it arrived in 2004, and then it spent 13 years in Saturn's orbit. I have three big areas of expertise. The first one I would say is planetary lightning. The second one is magnetospheric and planetary radio emissions. And the third one is calibrating the antennas. I was the first person to detect lightning on Saturn. So I was called the weatherman of Saturn for a long time. To study these radio emissions, those antennas need to be calibrated. To do this, we take a model. And this is these golden models you see here in different scales. Cassini is 1 to 30 and JUICE is 1 to 40. And these we built, gold plate them and put them into a tank of water. And then on both ends, we put two plates, so we create an electric field to find out the reception properties of the antenna system. Usually spacecraft have a conductive surface, and that's why we model with gold. We use it to simulate the situation in space to find out the reception properties of the antenna system. Because without that, your measurement values would be wrong. We also use gold because it has very good physical characteristics. It is highly conductive, it is very durable, it cannot rust, and that's very good because if you would use a not noble metal, after some time it would get a thin oxidized layer and then our measurement will not work anymore. It's an interesting job. There are still lots to investigate. And when you look at the new field of exoplanets, you can say we have just started to explore our backyard. We have gone very far, of course, but compared to the size of the universe, we have not gone very far.
One space mission which will allow us to explore further than ever before is the James Webb Space Telescope. It's a collaboration between space agencies in Europe, the US, and Canada, and it features a 21.3-foot mirror plated in gold. Now, this is a revolutionary new piece of technology, and scientists hope that it will allow us to peer through dust clouds, to see stars as they form planetary systems, and maybe look at some of the earliest galaxies in the universe.
Then, of course, there's that next frontier. Exploring parts of space previously reserved for science fiction.
I have a temperament to understand how things work. I was always a kid who wanted to take things apart and put them back together again. What better place to satisfy that craving to understand than in the final frontier? What fascinates me about Mars is that it is almost like Earth, but different in fundamental ways that we take for granted. A perfect example is, in fact, oxygen. We are surrounded by a thick soup of oxygen. You take that away and everything is different, whether it's controlling your body temperature or whether it's lighting a rocket. The single thing you need the most of when we send astronauts, when we send our grandchildren to Mars, is going to be a very, very large tank of oxygen. I'm fortunate enough to be the principal investigator for the MOXIE instrument, the Mars Oxygen ISRU experiment that is on the Perseverance rover even now as a demonstrator for how we will one day make oxygen to support a human mission to Mars. On Mars, we are not surrounded by oxygen, but we're surrounded by a reasonable amount of carbon dioxide. Now, here on Earth, we would be surrounded also by carbon dioxide if the ecosystem we live in didn't serve to convert that to oxygen for us. That's what trees do, that's what plants do, that's what plankton does. So our mission, should we choose to accept it, is to make an instrument that breathes in CO2 and it breathes out oxygen. What MOXIE does to make oxygen is, conceptually, it's very simple. You start with a CO2 molecule, one carbon atom, two oxygen atoms. And our task is to pull oxygen atoms off of that molecule. The best, most reliable technology to do that is what's called solid oxide electrolysis, meaning we have a thin slab of hot ceramic, about 800 degrees centigrade, which selectively allows the oxygen ion to pass through and nothing else. Gold is critically important to make MOXIE work for a number of reasons. It's ridiculously stable. It doesn't oxidize or corrode easily. It's an excellent heat conductor. That's why the MOXIE box is all gold on the outside. There are times of the day where it just gets too warm to run MOXIE, so controlling temperature is critical. So what can we do today? Well, we can make up to 10 grams an hour of oxygen. You and I would breathe maybe 20 to 30 grams an hour. We're not far from where we would need to be if we were just providing breathing oxygen from astronauts. We're farther away from a system that can put out 2 to 3 kilograms of oxygen an hour, and that's what we'll need to fill up a tank over the course of about a year that would hold 25 tons of oxygen to allow that rocket to launch that's going to take our astronauts home.
The beauty of space exploration is in its vastness. There is always more to discover. And the same could be said about the relationship between gold and space. Because while gold can be used for exploring the cosmos is also the source of all of the gold here on Earth.
In 2017, we got a glimpse of something billions of years and light years in the making. For the first time in history, scientists observed the creation of gold. Two neutron stars had been drawing toward one another for millennia. One moment, they were 200 miles apart. 100 seconds later, and they had collided, generating fabled gravitational waves, perhaps the most anticipated event in modern astronomy. This triggered astronomers all over to try to capture the event with telescopes, and they did. What scientists saw that day was gold being created in space as part of one of the most dramatic and extraordinary events the universe undergoes. The gold created in this collision will cycle through the cosmos and perhaps one day will form part of another planet, just as all the gold we've ever known became embedded in the infant Earth billions of years ago. And as we've seen in this episode, that same gold from the depths of outer space is what helps us to get back into space, to explore the unknown.
From ancient origins, gold continues to be at the forefront of our exploration. It is crucial to the story of humans and space travel. But that is just one part of the story of gold.